Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, I and my friends will present our report in Code Khusus MTES 1132, Appreciation of Mathematics. My name is NASUHA binti ROSLI and I'm from MT3. I am PPSMP 2526 student. My title report is Analysis of Mathematics in Flood Relief Management.
Assalamualaikum warahmatullahi wabarakatuh. My name is ELLYSHA binti JUZAIRE. I am from MT3, PPISFP 2526, and the title of my project is Fair Division. So we will start our presentation.
Assalamualaikum and good day to our lecturer Puan Nurul Shazni binti Amdi Saleh. Today, I and my friends DHIA will be talking about our report in the application of mathematics in real world problem.
So when we hear about the word mathematics, many people immediately think about numbers, formulas, and also calculations. However, mathematics is actually much more than that.
Yes, mathematics is not only a subject that we learn in the classroom, but it also a powerful tool that helps us understand and solve real world problems.
In fact, many important decisions in life are based on mathematical thinking, even if we are not aware of it.
Yes, for example, when we choose the fastest route to reach a destination,
Or when we try to divide something fairly among a group of people,
we are actually applying mathematical concept in our daily life.
this shows that mathematics plays a very important role in helping us make decisions that are not only logical but also effective.
So, in this presentation, we focus on two important aspects of decision making in mathematics.
The first aspect is efficiency, which focus on how we can achieve the best outcome using the least time, cost, or resources.
And the second aspect is fairness, which focus on how we can ensure the decisions are just and acceptable to all parties involved.
These two aspects are very important because in real life, the decisions are rarely simple.
Yes, more real-world problems involve multiple factors, and sometimes there is a need to balance efficiency and fairness at the same time.
For instance, in emergency situations, decisions need to be made quickly, but at the same time, resources must be distributed fairly.
This is where mathematics becomes very useful because it provides a structured and systematic way to analyze problems and find situations.
Instead of relying on assumptions, mathematics allows us to make decisions based on logic, reasoning, and evidence.
So, in addition, mathematics model help simplify complex situations, making them easier to understand and manage.
This is especially important in situations where there are many variables involved, such as time, distance, and individual preference.
Through this presentation, we aim to show that mathematics is not just theoretical knowledge,
But a practical tool that can be applied to solve real-life problems effectively.
we also want to highlight how mathematics help improve the quality of decision making in different contexts.
By understanding these applications, we can appreciate the true value of mathematics in our daily life.
Because in reality, mathematics is not just about getting the correct answer,
But about making the best possible decision in a given situation.
So, in this presentation, I will focus on how mathematics is used to improve efficiency, particularly in disaster management.
And later, I will explain how mathematics ensures fairness in decision making through the concept of fair division.
So, let us begin the first part of our presentation. So, right now, I will continue to present my report about the analysis in mathematics in flood relief management. Imagine a situation where a flood suddenly occurs, affecting multiple areas at the same time. Several evacuation centers urgently require food supplies, medical assistance, and rescue support. In such situation, time becomes a critical factor. Even a small delay can result in serious consequences, including the loss of life. Therefore, the key question is how can we ensure that aid is delivered in the fastest, most efficient and most reliable way? So, to answer this question, we must turn this to mathematics, specifically graph theory and optimizing algorithm, which allow us to analyze complex situations systematically and produce effective solutions. In real-life disaster management, decisions are often made based on human intuition or past experience. While this may work in simple situations, it becomes highly unreliable in complex and time-sensitive scenarios. This is because disaster logistics involve multiple interrelated variables such as distance between locations, travel time under uncertain conditions, road accessibility affected by flood, and availability of vehicles and resources, and urgency level of different evacuation sectors. These variables are not independent. They influence each other dynamically. For example, a shorter road may not necessarily be faster if it is flooded or congested. Similarly, prioritizing one location may delay aid delivery to another. Human thinking has limitations when dealing with such complexity, especially under pressure. As a result, relying solely on intuition may lead to inefficient route planning, delays in aid distribution, unequal allocation of resources, and increased risk of victims. So, therefore, mathematics provide a systematic and objective framework for decision making. Through mathematical modeling, complex problems can be simplified into structural components, analyzed using logical relationships, and solved using algorithms that optimize outcomes. This allows decision makers to move beyond guesswork and make data-driven decisions. In this way, mathematics transforms uncertainty into a structure and management system. So right now, I have two situations to compare which one is better. First, situation A, conventional approach. In this approach, road planning is based on fixed distance between locations. This method assumes that all roads are accessible and conditions remain constant. However, during flood, this assumption becomes invalid because road may be blocked or damaged, transportation capacity may suddenly drop, and travel time becomes unpredictable. Since the system does not adapt to this change, it often leads to vehicles being stranded, repeated travel routes, delay in reaching evacuation center, and inefficient use of fuel and resource. This shows that conventional methods are not suitable for dynamic and unpredictable situations. Okay. For second situation is situation B, mathematical approach. In contrast, the mathematical approach uses a dynamic and adaptive model. In this system, key variables such as route capacity and each weight which represent cost, distance or travel time are continuously updated based on real-time conditions. For example, if a road becomes flooded, the system automatically increases the cost of that route and search for alternative paths. Although the alternative route may be larger in distance, it may still be faster and safer. This demonstrates that mathematics focus not only on minimizing distance but also on optimizing overall efficiency. More importantly, it allows for real-time decision-making, which is essential in emergency situations. To model the system, I use graph theory, where each location is represented as a vertex, and each route is represented as an edge. This representation allows us to visualize and analyze the network of connections systematically. Initially, using a conventional method, it is delivered through separate grids from the depot to each evacuation center. This results in a total traveling distance of 96 km. This method is inefficient because it ignores the relationship between location and cost-repeated movement along the same routes. Okay, to improve my mathematical efficiency, I apply apply the Clark and Wright savings algorithm. This algorithm works by calculating the savings obtained when two routes are combined into a single route. It evaluates all possible route combination and selects the one that provides the highest reduction in total distance. Based on the highest saving value, the optimized route becomes depot to P1 and P2 and P3 and depot. This reduces the total travel distance to 90 km. Okay, to improve my mathematics efficiency, I apply the Clark and Wright savings algorithm. This algorithm works by calculating the savings obtained when two routes are combined into a single route. It evaluates all possible routes in combination and select the one that provides the highest reduction in total distance. Based on the highest saving value, the optimized route becomes depot to P1, to P2, to P3, and to depot again. This reduces the total traveling distance to 60 km. Therefore, the total reduction is 36 km, where 96 subtract to 60 km, and the percentage improvement is 37.5%. This is a significant improvement as it reduces travel time, fuel consumption, operational cost, and risk of delay. More importantly, this improvement ensures that it reaches victims faster, which can be life-saving in critical situations. So, this analysis clearly demonstrates that mathematical models are not just theoretical concepts, but practical tools that can be applied in real-world disaster management. They provide precision, efficiency, and adaptability, which are essential in handling complex and unpredictable situations. So, for conclusion in my report is, mathematics play a critical role in disaster management by enabling efficient, accurate, and adaptive decision making. It allows us to overcome human limitation and rely on logical data-driven solution. This proves that mathematics is not only about numbers and equations, but also about improving system, enhancing efficiency, and ultimate saving life. So, right now, I would like to hand over this presentation to my partner, DHIA, who will present another important application of mathematics, which focus on fairness in decision making.
Thank you, Ain. While Ain has explained how mathematics ensures efficiency in disaster situations, I will present another important role of mathematics, which is ensuring fairness in decision making through the concept of fair divisions. In many real-life situations, people are required to share limited resources such as land, money, food, inheritance, or even time and opportunities. However, conflicts often arise because each individual has different preferences, needs, and perceptions of value. For example, one person may value something based on economic benefit, while another may value it based on personal use or emotional attachment. This difference in perception makes it difficult to achieve a decision that is considered fair by all parties. Without a structured method, decisions are often made based on negotiation or personal opinion. This may lead to dissatisfaction, misunderstanding, and even long-term conflict. In some cases, it may also create inequality, where one party feels disadvantageous. Therefore, mathematics provide a systematic and objective approach to ensure fairness and reduce bias in such situations. Now, one of the most fundamental methods in fair division is the divide and choose method. In this method, one person divides the resource into parts, and the other person chooses the part they prefer, which is small or big. This method ensures fairness because the divider must divide the resource as equally as possible. If the divider is unfair, they risk receiving the less preferred portion. Therefore, this method creates a natural incentive of for fairness. Although this method appears simple, it also actually involves strategic thinking and mathematical reasoning. The divider must consider how the other person values the resources, while the chooser selects based on their own preference. This interaction ensures that both parties are satisfied even if their preferences are different. Now, I give an example from my fair division project. So, for example, consider a situation where two siblings are dividing inherited land. One sibling may prefer land near the main road due to its commercial value, while the other prefers land near a river for agricultural purposes. Since both individuals assign different values to different parts of the land, conflict may arise if the division is not handled properly. By applying the divide and choose method, one sibling divides the land into two parts that they believe are equal, and the other siblings chooses their preferred portion. As a result, both parties feel that the outcome is fair, even though they may value the land differently. In addition to this method, fair division also involves important mathematical concepts such as proportionality and also envy-free allocation. Proportionality ensures that each individual receives a share that they consider fair based on their own valuation. Envy-free allocation means that no individual prefers another person's shares over their own, which reduces the feelings or dissatisfaction or jealousy. I believe that these concepts highlight how mathematics can transform subjective perceptions into objective outcomes. Instead of relying on emotions, assumptions, or negotiation alone, mathematical methods provide clear rules that guide fair decision making. Furthermore, fair division is not just limited to simple situations. In more complex scenarios involving multiple participants, advanced algorithms are used to ensure fairness among all parties. These algorithms are applied in various real-world fields such as economics, resource allocation, and also policy making, and even digital platforms. This shows that fair division is not only theoretical but also widely applicable in modern society. Another important point is that fairness itself is not always equal distribution. Instead, fairness depends on how individuals value the resource. Therefore, mathematical models focus on perceived fairness rather than just equal division. This makes the solution more realistic and acceptable in real-life situations. In conclusion, mathematics plays an essential role in ensuring fairness and reducing conflict in society. It provides structured and logical methods that help individuals make balanced and rational decisions when sharing limited resources. Just as Einstein's topic focused on efficiency in critical situations, my topic demonstrates that mathematics is equally important in ensuring fairness in everyday life. Together, both topics show that mathematics is a powerful tool for solving real-world problems from different perspectives.
So yeah, after presenting both our topics, I think it's really interesting how mathematics actually plays a role in real life decision making, not just in theory.
Yes, I agree. Before this, I always thought mathematics was just solving questions or formulas. But now I realize it actually helps people solve real-world problems in a structured way.
In my case, mathematics help improve efficiency, especially in emergency situations like floods, where every second is very important in our life.
And in my topic, mathematics helps ensure fairness, especially when people need to share limited resources and avoid conflicts.
And what I find really interesting in that both of our topics are actually connected through decision making.
Yes, but from different perspectives, yours focus on efficiency and speed, but mine focus on fairness and and satisfaction.
And I think this shows that mathematics is not just about finding answer, but making the right decision in complex situation.
That's true, because in real life, a good decision is not only about being correct, but also about being fair and acceptable to everyone involved.
As for me, for example, in disaster management, even if it is delivered quickly, it must also be distributed fairly among victims.
Yes, because if the distribution is not fair, it may create dissatisfaction or even conflict among people who are already in a difficult situation. So in a way, mathematics does not only solve problems, but it also helps maintain harmony in society.
And in your topic, even if the division is fair, it should also be efficient and practical to apply in real life.
Exactly. If a method is too complicated, people may not use it even if it is fair in theory.
So I think mathematics help us balance both efficiency and fairness in decision making.
Yes, and it provides a logical framework that reduces emotional bias and subjective judgment.
So without mathematics, many decisions would depend on assumption. But with mathematics, decisions are supported by logic and evidence.
Another thing I noticed is that mathematic models are very adaptable.
Yes, they can change depending on the situation and the variable involved.
Therefore, in my case, the value of resources depends on individual preference.
And in my case, route change due to floods and real-time conditions.
This shows that mathematics is not rigid, but flexible enough to reflect real-life complexity.
And I also think mathematics help us think more critically.
Yes, because it trains us to analyze situations, evaluate options, and make logical decisions.
It teaches us not just what to think, but how to think.
And that is very important, especially in situations involving multiple people or high-risk outcomes.
As a future educators, I think it is our responsibility to change how students perceive mathematics.
Yes, we should help them understand that mathematics is not just about exams, but about solving meaningful problems in life. If students can see the value of mathematics in real life, they will not just learn, but appreciate it.
So overall, I think both of our topics show that mathematics is deeply connected to real life.
Yes, whether it is about managing disaster or sharing resources, mathematics plays an important role in our life. In conclusion, mathematics help us make decisions that are more logical, balanced, and fair.
Therefore, mathematics is not just a subject we learn, but a powerful tool that shape the way we think, make decisions, and improve the world around us.
Yeah.
Okay, that's all from us.
Thank you, Puan, for watching our video. Bye!